Hello there. So the question at hand is to find the height of a binary tree. And in order to solve this problem, even though this can be solved using depth first search and breadth first search, we are going to solve this for this video using the depth first search. So to find the height of a tree, it is intuitive that we perform the depth first search, go to the very depth, and all the while track the depth at which we are getting into, and then out of all the depths, keep track of the max depth, and as final answer to our problem, return that depth, which is the height of the tree. So for this example that we have, that is a tree with 4 nodes, the height will be, if I were to say this as 1, this as 2, and this one as 3, so the height would be 3. And if we were to perform the depth first search, there is a possibility to solve this problem using two variations, slight variations even though. So one way is to start the depth first search from the root, go to the leaf node, and when we are at leaf, start counting as 1, 2, and 3, and return and keep this 3, and similarly do this for the right subtree as well. So we have the left subtree, this is the left subtree, and this is the right subtree. So what we do is we do the depth first search to the left, find the height of the left subtree, and we do the depth first search to the right and find the height of the subtree coming from the right subtree, and then take the maximum of 3 and 2, and that is 3, and that is the height of a binary tree. So that is one approach. The other approach that is possible for this problem is, instead of going and hitting the leaf and then start counting up, we can actually count down as we go. So the approach could be like, we start from 1, we go 2, we go 3, and 3 is a leaf node, so we keep track of 3. Then again we start do the depth first search for all possible branches, and another possible branch will be to go to this leaf and hit 2, and when we hit the leaf node, we just compare the previous max that we have and update the maximum value that we attained. So for this we have 2 leaves, one is at a depth of 3 and one is at a depth of 2, and out of which the max of which is 3, and that is our answer. So again, to recap, we have two approaches. One is to hit the leaf first, and as we start getting out of the recursion calls, as we start getting back up, we count it up from bottom to top. And the other way is to, as we start the depth first search, we all the way along keep counting the depth and return the max of all the leaves, depth of all the leaves that we traversed using the depth first search. So these are the two fundamental ways that we can use to find the depth of a tree, or that is the height of a tree, and we will use depth first search function or the approach or the code to implement these idea. So next up, I'm going to switch to my editor, and we are going to program it. So here we are back to our editor. What we are going to do is, as we discuss the depth first search approach or variations for finding the height of the binary tree, we are going to implement it. So I have already set up the tree from the example that we saw on the whiteboard, and the only thing is left to do for us is to create the function for performing the depth first search and finding out the height of the tree. So let's begin. First of all, we will proceed with the method 1, which is counting upwards. That is, we hit the leaf node and then we start counting upwards. So I'll create a function by the name height, whose job will be to return me the height of the binary tree. And as an argument, I'll pass node, or better, I'll call it root. if the root is equal to none, that is it's not there, what I want to do is I want to return the height as 0, so return 0. Other than that, I want to do the depth first search of the left tree and the right tree, so this will be a recursion call similar to what we do in depth first search traversal technique. I'll do the similar for right. So height is function is acting like a traversal function. The only difference is it is going to return me the height as it traverses the tree. So L and R are the corresponding left subtree and right subtree height. And what I'm going to do is I'm going to return the max of L comma R, that is left subtree and right subtree. I'm going to get corresponding heights and I'm going to return the max of it plus 1. So if you are just new to depth first search technique and not very familiarized with it, it is a possibility that there might not be a certain 100% clarity on how the height function is returning the height of the tree. So just remember that you can always pick up the pen paper, plot the tree and follow the algorithm line by line, track the recursions and just get a very firm grip over the algorithm and get the clear idea of how it is working by just following the algorithm line by line and tracking the recursions. So that is always an option, and I recommend that if this is your one of the first times you are dealing with depth first search. But other than that, I expect you to understand it very nicely if that's not the case. So anyways, we are done with the height, finding the height using depth first search traversal on the variation 1, that is counting upwards, that is hitting the leaf node and then counting our way upwards. So now I'm going to quickly test the function if it is functioning correctly. So what I'm going to do is I'm going to print and make the call to the height function, and I'm going to insert or give the argument of root as n, and this n is coming from over here, that is the root. So I must add it here, that this is nothing but the root of our tree that we have created, and I'm passing it as an argument, and the function should return me the height of 3. Let's see that. And yes, it is returning me 3. So basically this node returns us the height of 1, this returns height of 2, this node returns height of 3, and from here it returns height of 1, this returns height of 2, and out of the 2 of 3 and 2 we pick the maximum, that is 3, and that is our answer. So now let's make the code for finding the height of the binary tree going downwards, and it will be a good exercise to just observe the changes in the line of codes and approach. So as a part of the method 2, which is counting down, what I'm going to do is I'm going to define the height function, and this height function is going to take 2 arguments, that is one is root and the other one is the height. So what I'm going to do is, first of all, if there is not the root, that is if root is equal to none or not root, what I want to do is I want to return the height. Other than that, very similar, I'm going to define or calculate the height of the left subtree by making a recursion call, that is depth first search approach, and in the fashion I'm going to pass node plus left as the node, and height is going to be plus 1 because now we are going to the child, and going to the child means that whatever the height is at this node or root, I want it to be increased by 1. Similarly I will do it for right node as well, and then at last I want to return the max of the 2 subtrees, that is L and R. Now again, I would recommend that it is a good idea to pick up your pen and paper, plot the tree, go through the lines of the algorithm, track the recursion calls, and there you will have it, the proper and crystal clear understanding and hold over this solution or over this function. Now just to verify the results, I'm going to print the output on the screen. So this is going to be method 2 height equal to, I'm going to make the call to the function height, and as an argument I'm going to pass the root as n and height equal to 0 for node, or node height equal to 0 as the initialization. So now I'm going to run this function or run this program and see if we get the desired output. So there is some error. What I will do is I'll just clarify that this is nothing but the ht variable that we defined. So what I will do is ht is equal to 0 and root equal to n. Run the code and there we have it. From method 2 we get the height of 3 and the above 3 is coming from the method 1. So if I were to just keep things more organized, I'll copy paste it over here, and this is coming from method 1. And there we have it. Method 1 height is equal to 3, method 2 height equal to 3. Both the functions perform the exact same task in the exact same time complexity, but the only difference is in the approach. One of them counts downwards, that is the method 2, which counts downwards as it goes downwards using the depth first traversal, whereas the other one counts upwards. It performs the depth first traversals, reaches the leaf node, and then as it comes back to the root, it starts counting up.